Very good evening to all of you. Welcome back to the class of BAA2213, the Reinforced Concrete Design 1. In this class, I will discuss or show on how to determine the value of nominal cover. Okay, so the nominal cover is the distance. Okay, it's the distance between the surface of the reinforcement closest to the nearest concrete surface, okay, including link and stirrups and surface reinforcement where relevant. Okay, so this is the cross section of the beam of a beam as an example here. Okay, you can see that this is the nominal cover. Okay, from this side of the steel. Okay, this is the top side of the steel until the top part of the beam. So this is the nominal cover. Okay, and this is for from this edge, okay, the outer edge of the steel to the uh, side of the beam. Okay, this is we not call as nominal cover. Okay, it is necessary to provide a safe transfer of bond forces, and we must provide the nominal cover for adequate durability, which is protection against the corrosions and for fire resistance. Okay, and then the value of C minimum, before we can determine the nominal cover, we have to determine the value of C min, which is influenced by the exposure classifications, mixed characteristics, and the intended design life of the structure. Okay, the C nominal can be either spacer blocks, okay, or the spacer blocks might be from the plastic or by the mortar. Okay, this one. So they say this is the they say on site they call it as tauhu. Okay, this is the bahasa site tauhu. Okay, tauhu. Let's say your C nominal is equal to 30 mm. So then the workers will provide uh, a layer of 30 mm of this. Okay, the thickness is 30 mm of mortar. Okay, which is the cement plus sand and plus water. Okay, and then they will mix, and then they will lay on the uh, horizontal place. Okay, like this one. I draw it here. Okay, this one. Okay, they will lay the horizontal place. This one. Okay, the thickness is 30 mm. Okay, about 30 mm. Okay, because it's your C nominal, and then they will provide with the uh, dawai dawai. Dia akan cucuk dawai kat sini. So dia akan jadi macam ni. This is your C nominal, and then this is your ada satu dawai. Masa dia basah dia akan cucuk, and then they will cut just like to cut the cake. They will cut masa dia masa dia belum tak adalah basah sangat. Waktu dia maybe lepas 1 jam, dia akan potong dan nanti dia akan mengering, dan setiap satu unit ni akan ada dawai terkeluar. Okay, dan dawai terkeluar tu nanti akan diikat dengan let's see kat sini dia dia akan buat this one. Before you provide you provide this beam, the workers will provide the formwork. Okay, let's say this is the formwork for the beam. Okay, the side, this is bottom timber. Then this is for the side, and then this is the strut. Okay, this is the formwork, and then they will put the cover, the spacer first, as the cover. So this one, this is the cover. They will put it here, and then here, and also here. Let's say here. Okay, and then they will install the steel. Okay, this is the for the link. Okay, Okay, this is the link, and then the link and the main bar will be provided at the same time. Okay. Okay, and then that's why they need ada dawai tadi. Dawai tadi tu keluar akan diikat kat sini. Diikat bersama-sama ni. Because we don't want the concrete cover to be flow. Okay, kita tak nak dia hanyut semasa proses concreting. Okay, and then dia akan ikat sini. Ikat. This is dawai tadi yang terkeluar daripada concrete cover, and then they will pour the concrete. Okay, during the process of concreting, without this dawai ni, mungkin concrete cover tu akan hanyut. Okay, so this is how to determine the value of nominal cover. Okay, this is the C nominal. C nominal is C minimum plus standard deviation. Okay, the value of standard deviation is equal to 10 mm. This one, 10 mm. Okay, so this one for this case, okay, this is the you can refer to this notes later. Okay, this is for durability. Okay, this is based on this is C minimum due to C min B is C minimum due to bond requirement. Okay, and then C min dur means for durability, which is for due to environmental conditions. Okay, and then 10 mm. So you select the maximum value, okay, the highest value as the C minimum. Okay, so here for C minimum, C min B with regard to the bond is equal to the diameter of bar for our case. Okay, because our bar is separated and not bundled. Separated means this one, 1, 2, 3. Okay, it's separated, so it's equal to the diameter of the bar. It's okay. We will take a look on the example later. So, and this is for the exposure classes. Okay, the class, and then this is the description. Okay, we have X0, Xc1, Xc2, Xc3. Okay, depend on the risk of corrosion. This is the risk of corrosions. Okay, let's say for case Xc1 to Xc4, this is the risk of corrosion induced by carbonations. Okay, and then this is the situation, and this is corrosions by chlorides. Maybe this is the structure which is exposed to the chlorides from waters. Okay, like the swimming pool. Okay, car park slab and so on. Okay, and then this is the corrosion induced by chlorides from seawater. This is for structures near to the coast area. Okay, and for the parts of marine structures, such as the deck. Okay, so this is the value of C min dur. Okay, for durability. Okay, based on the structural class. Okay, for the structural class for design working life of 50 years. Okay, if the building is designed for 50 years, so the structural class is S4. Okay, S4. So this we refer to the S4, and then we refer to our exposure class. Okay, either X0, Xc1, Xc2, and so on. So, and the allowance of deviations, okay, C deviations is 10 mm. Okay, and then this is okay, we have C min due to bonding, okay, which is equal to diameter of main bar. Okay, and we also have the C min dur, okay, which is depend on the exposure of the element. And then we also have to find the C min for the fire resistance versus fire resistance. So this table is for simply supported beam. Okay, make sure you refer to the right table. This is for simply supported beam. And this one is for continuous beam. And this is for columns. Okay, so be careful to select your table. Okay, I don't want to waste our time, so let's go for the example. Okay, so I will I will show you on how to select the table. Okay, I mean the value in the table. Okay, so exercise. Exercise 19, yeah. Okay, see nominal. Exercise 19. So it's okay, just follow from these notes, but I want to show you how to select the value. Okay, for this is the situation. Design the concrete cover of a reinforced concrete beam. Okay, the first keyword is beam. Okay, so our problem is about the beam. Okay, our situation is for beam. And then the fire resistance is R60, which is for 1 hour. Okay, fire resistance is equal to R60. So you refer to the only refer to R60 from the table letter. And the concrete class use okay, C25. Okay, C25/30. And then the longitudinal reinforcement bar is 5. Okay, the size is 20. The stirrup is 8. So what is the size of uh the diameter of the bar here? Diameter of main bar. Okay, can you tell me?
20.
Okay, good. Diameter of the main bar is 20. Okay, don't confuse. Okay, 20 mm. Okay, and then the maximum aggregate is 20, which is lesser than 32 mm. The design working life is 50 years. Okay, design working life is equal to 50 years. Okay, so the class is S. Okay, according to this table. Okay, according to this, okay, is S4. Okay, S4 is our design working life. So S4. And then what else we have to know? Okay, normal quality control is put in place. Okay, so as the solution, the basic is this one. Okay, as a solution. Okay, dia dah bagi kat sini. Exposure class is XC1. Okay, exposure class XC1. Okay, sometimes this one is not given. They will give the situation, so you must determine the exposure class. Okay, so the basic of your solution is C maximum, C nominal is equal to C minimum plus standard deviation. And then the C minimum is equal to maximum between C min B for bonding or C min durability and or this one macam ni saya tulis dia or 10 mm. Okay, and then the C minimum also we have to take a look for the fire resistance. It's okay. So the C minimum, okay, with regard to the bond, okay, C minimum, okay, C min with regard to the bond is equal to, must equal to, you refer to this table. This is very simple. I hope you will remember this one. Always always equal to the diameter of the bar. Okay. So this is equal to diameter of main bar, which is equal to 20 mm. Okay, and then clear. So about the C min durability, so you refer to the table. So it is given that the value of our X4 is our design the design working life is 50 years. So we refer to S4 here. And then XC1. Okay, XC1 is here. Here is your XC1. This is the given exposure class. So your C min dur is equal to this one. You bring here and you bring here. So equal to 15 millimeters. Okay. But sometimes they will not give you directly the XC1. They will give you this value. Okay, they will give you, let's say the situation, the concrete is inside the buildings. Okay, concrete is inside the buildings with very low air humidity. Inside the buildings mean X0 if the very low air humidity. Okay, so inside the building, so maybe this one also inside the building. Concrete inside the buildings with moderate or high air humidity. If just inside the building, okay, so you can assume the air humidity either very low. Here you can see the air humidity, you can assume either very low and then low air humidity, say still inside the building. Okay, inside the buildings, low and then moderate or high. Okay, this one will differentiate the class either XC1, XC2, XC3 or XC4. Okay, it depends on the situations. Okay, if you have the word is inside the buildings, okay, so if the situation given is inside building with very low air humidity, so it is clear that it's X0. If just very general is inside building, so you have to assume the air humidity. Okay. Okay, so the situation here is the C min duration dur is equal to 15 mm. So equals to 15. Sorry, based on the table, is equal to 15 mm. Okay, and then refer back here. So about the fire resistance, okay, the ASD is equal to 30 plus 10. Okay, sekejap ya, kita tengok apa itu 30 plus 10. Okay, so here we have of regard with regard to fire resistance. Okay. Okay, regard to fire resistance R60. So we must understand this one. Okay, ASD minus link minus C bar. Okay, ASD is equal to 30 plus 10. Okay, where they get this value? Okay, 30 plus 10, fire resistance is this one. And then the size of the beam is 200 times to 450. Okay, the size of the beam is, this is another information. Please don't miss this one. B is equal to 200, H is equal to 450 mm. Okay, so we refer to this one. Okay, refer to the correct table. Okay, for this one, it's not clear. Either the beam is simply supported or continuous. It's not clear. Okay, it's okay. Let's just restudy this one together. The value is A 12. Okay, yeah, maybe the case is for simply supported beams. Okay, so the this one tengok balik. 30 tambah ASD. ASD sama dengan 30 tambah 10 sama 40. Okay, the ASD is here. You can refer to this table, to this figure. ASD is the distance from the side of the concrete, okay, side of the beam to the center of the first main bar. Okay, this is the ASD. Okay. This is column. This is column. Okay, this. Okay, the given value is 30. 30, so you plus 10. Okay. Okay, this one, you can refer to this one. Okay, this one, ASD is equal to this one, see notes here. ASD is A plus 10 mm. So that's why it's plus 10. So this is the value of A. A. This is B minimum and this is A. Okay. So the value of our beam size is 200. Here the question, 200 mm is our size, our width of the beam, and R60, and then we refer to our B is 200 mm. So our A is equal to 30. Okay, our A is equal to 30. If the size of the beam is equal to, let's say, our beam is equal to 250 times 500. Okay, what is the value of A? Any question? Any answer? Because 250 is not here. Okay. No 250 here. So which one to select? If the B is 250.
Ambil yang
300.
300. Okay, one answer. And another answer tadi saya dengar?
ambil yang lebih kurang daripada 30. Macam ambil 200.
Yes, you ambil yang lebih kurang. Okay, you select the lesser one. Okay, select the lesser one. So you select, if your width is 250, so you select 200. Okay, because if the fire resistance is passed for 200, so automatically it will pass for 250. Faham tak? Kalau dia boleh resist untuk 200, so dia bolehlah resist untuk 200.5. So that's why kita ambil yang paling, kita ambil yang lebih rendah. So kalau you punya, let's say 3 to 5 mm, our B, so nak ambil yang mana?
300.
Yes, you can select for 300. Okay, if it pass for 300, surely it will pass for 3 to 5, insyaAllah. Okay, so if your beam is 175, so you select for this one. Okay, 160. So our value is 30. So that's why in this example, our AS is, okay, so this one, our ASD is equal to A plus 10. Okay, our AS from table, table is, okay, A is equal to 30 mm. Okay, you can write down what table you refer. Okay, let's say this is table 5.5. A is 30 mm. So you write down here ASD is equal to A plus 10 equal to 30 plus 10 equal to 40 mm. Okay. So C minimum is equal to ASD. Okay, sekejap ya. Okay, so C minimum is this one. Okay. Itulah C ASD minus link and then minus bar over 2. Because this is our, okay, I enlarge this one. I hope you can see clearly. So this is okay, I hope you understand this one. Very clear that this is here, from here to the center of the main bar is your ASD. Okay, so you can calculate here. This is the link. So this is minus link and minus diameter bar over 2. This is your C minimum. Okay, it's I refer to the side. Okay, so here okay, ASD minus link minus bar. Okay, okay, so C minimum with regard to fire is equal to ASD minus diameter of link minus diameter of main bar over 2 equal to ASD equal to 40 minus our link here is okay, stirrup. Okay, stirrup also links. Okay, this is stirrup also equal to link or equal to shear reinforcement. Okay, please don't confuse with the terminology. So minus link is equal to 8 and then minus 20 over 2, so equal to 22 mm. So the minimum, okay, the C minimum, okay, with regard to the, okay, here your C minimum is equal to okay, here let's say C minimum equal to this one. Okay, you fill in this requirement. Maximum between C min bond is 20 mm. Maximum between 20 mm or C min durability is 15 mm or 10 mm. Okay, that's your C min. So you select the maximum value. The maximum value is equal to 20 mm. Okay, from this situation, your C minimum is equal to 20 mm. However, you have to refer to the C minimum with regard to the fire resistance. So the C minimum with regard to the fire is equal to 20 mm. So you select the highest one. Okay. Select the highest. So for this case, your C minimum is 20 mm. Therefore, your C nominal is equal to C minimum plus standard deviation equal to 22 plus, okay, standard deviation is 10 equal to 32 mm. And then you round up to the increment of 5. Okay, the increment should be 5. So you use C nominal is equal to 35 millimeter. Okay. Because usually they use 25. This is typical. Okay, 25, 30, 30, 35 mm, 40 mm, 45 mm, and then 50 mm. So if your calculation shows that C nominal is equal to 26, so what should you use? What is the value you use?
30.
Okay, 30. Okay, so you go to C nominal is equal to 30. Go to the higher by increment of this one. Okay, 5, 5, 5, 5, 5. Okay, clear? This
Yes,
is simple, but the most challenging one is to extract the situation given. Okay, the situation will be given by text. So let's say this one, and then this one. The situation is here inside the building with what level of air humidity. So you have to select XC1, XC2, XC3 or XC4. So let's say here, nampak XC3, XC4 dia punya ni pun dah lain dah dia punya ni value dia. So be careful. Okay, be careful about this one. Okay. Okay, let's take a look on another example. Okay, let's do 8 je di 5. This is example for 1 hour resistance. Let's say this a simply supported. Okay, so you refer to simply supported, and then inside building subject to 1 hour fire resistance. Okay, this is the example of the questions. Okay, inside building subject to 1 hour fire resistance. 1 hour fire resistance mean R60. Okay, the exposure class is XC1 because it's inside the building. But this the situation is never it not mention the situations. Okay, either the situations about the air humidity. Okay, this one inside buildings. This is also inside buildings. Concrete inside buildings with moderate or high. So dekat dapat XC2, XC3 kan dah lain kan dia punya ni value dia. XC2, XC3 25, ini pun dah ni 15. So for in this case, if the questions just very general, just mention that inside the buildings, so you just assume okay, just assume the level of air humidity. Okay. So you can select this one, okay, XC1. Okay. So you can take a look later, okay, from this example 1.11. Okay, you can check from your module. Okay, I think this it's quite similar to this is similar. Okay, this is similar to what our did just now. Okay, the conclusion is use C nominal equal to 35 mm. So how about another example? Maybe we have another example for beam. Okay, also this is also simply supported. However, the C nominal is given for this example. Okay. Okay, this is also given for nominal concrete cover. Okay, this is example lah, example for your project. Okay. Okay, how to select the maximum moment, okay, for mid-span and support. You can refer to this one. Okay, and then this is the final detailing. Okay, tak ada. Okay, no detailing. Okay, detailing, so you can refer our last class. Okay. Okay, so for column 218, okay, result of non-slender column bent about major axis. Okay, let's take a look on this example. Okay, in your slide is module page berapa tu? Page 217. Okay, 217. Page 217 in your module. So you can study this one. Okay, this is about the column. Okay, exposure class is RC1. Fire resistance is 1 hour. Okay, and then the minimum bar is 20 mm. So you can see here that it is very clear that C mean B is equal to 20 mm because the diameter of bar is given as 20 mm here. Okay, so it's clear, betul macam bawah ni. Okay, and then exposure class is XC1. Okay, XC1. So and then our design life is 50 years. Okay, just like what we did just now. So here, this one, XC1 and S4. So it's 50 mm. C mean durability. Is 15 mm. So C mean is equal to maximum between C mean B is 20. Okay, 20 is C mean B, and then 15 mm, and then 10 mm. You have to select the maximum first. So your first selection is 20 mm. Okay, clear? 20 mm. But with regard to fire, okay, let's refer with regard to fire. Okay, A is equal to what from the table? Okay, with regard to the fire is 1 hour fire resistance. Okay, means R60. So the ASD is equal to 36. Okay, let's refer. Okay, ASD is equal to 36. ASD, what is the ASD for fire, for column? So this is for simply supported beam, this is for continuous beam, and this is for column. Okay, for column, please give attention here. Okay, R60, and then column exposed on more than one side. Okay, this is the exposure. Okay, the position of the column. Okay, let's say this is more than one side. Let's say this is your building. This is the brick wall. This is the brick wall. So this is no brick wall here. A and B. Okay, no brick wall. So the column is exposed more than one side. So if the column is exposed on one side, let's say you have a brick wall here from A. So only one side is exposed. Okay, but if you have all the four sides, okay, have brick wall. So you refer to this one, okay? You refer to this one as minimum. Okay, so we refer back. Okay, 200 mm. Okay, so the side is 200 mm here. The size 200 or 250 actually. 200 mm, and so the ASD is equal to 36. Okay, ASD is equal to 36. This one, axis distance A of the main bar. Okay, this S is distance. So inilah A. OASD. Okay, I'm not sure about the column actually. 36. So this one 200 mm. So 200 mm is 36. Okay, the A. Okay, the distance. Okay, actually distance A. A is equal to, so A also. So this one this. Okay, sorry, because for the column the concrete is similar. Okay, let's say for the beam maybe bottom cover is okay, bottom cover at the bottom here is not similar to the side cover. Okay, maybe bottom cover is 30 and side cover is 25, let's say. So but however, for the column the cover is similar for all around. So okay, this one is okay, because this example we don't know what is the value of this one. So you can assume lah, okay, you can assume inside your answer you can assume. Okay, just write down, assume that UFI is equal to 0.5. I is equal to 0.5. So A is equal to 36 mm. Okay, A equal to 36 mm. So A is equal to this one. Sama saja macam tadi. So you just refer. Okay, so this is the A is distance from here, from the center of the bar to the side of the side of the concrete. And then so you have to minus, okay, this is your C minimum. This is your C minimum. So you have to minus the length and then minus the diameter of bar over 2. Okay, just like in here. So 36 minus, okay, length is 6 mm. So sama lah ya, dia punya ni. This is quite critical, okay. Critical is the fire resistance. Okay, so C minimum is equal to A minus dengan diameter of length minus dengan diameter of bar of main bar over 2 to 36 minus length is 6 minus 20 over 2 equal to this one okay, sama je. So 20 mm. Okay, so sama lah. Okay, kat sini pun this one okay, from due to durability due to bond 20 mm. This is also 20 mm. Okay. So 20 mm. So C minimum is 20 mm. So C nominal is equal to C minimum plus deviation is equal to 20 plus 10. So directly as 30 mm as your nominal cover. Okay, so what happened? What happened if our diameter of bar is equal to, okay, let's say we change our diameter of bar. Diameter of main bar is equal to 25 mm. So here main bond is changed to 25. Here is also 25. Okay, here is 25. So can you help me? Here 36 minus 6 minus 25 over 2. Go to 17.5. Okay, 17.5 mm. So you select your C minimum is equal to this one, 25. 25 is your C minimum. Okay, so 25. Now here is 25 plus 10. So it's equal to 35 mm. C nominal. Okay, so be careful about the classification. Okay, of this one. Assume delta apa? Mu phi is equal to 0.5. So you can select this value from the table. 36 is your A. Okay, so if your column is 400, so your A is 31. Okay, if your column size is 400, let's say 400 by 400 square column, so you select this one. Okay, 31. And then you do the calculations. Okay, class? Any questions about this one? Okay, if no questions, you can okay, if no questions, you can proceed with your beam design. It's okay for your beam design, you can assume the C nominal. Okay, you don't have to recalculate this one. But during the actually you have to calculate, but it's okay lah. You just assume for your waste project you can assume. But for the real working environment, you have to determine, okay, which is based on your exposure class, okay, your structural class and your fire resistance. Okay, so thank you very much for your attention. See you next week.